Let's explore Docker image layers and understand container architecture. Docker image layers are fundamental to how Docker builds efficient and reusable images. They are based on a layered architecture. Let's dive in and see how it works. A Docker image is a read-only template used to create containers. Consider it a snapshot or a blueprint of your application and its environment. A Docker image contains everything needed to run an application. This includes the code itself, the runtime environment it needs such as Java or Python, any libraries it depends on, and all the necessary operating system level dependencies. Docker images are built in layers much like an onion. Each layer represents a file system change and is stacked on top of the previous one. Consider the image consisting of, at the very bottom, the base operating system. Then you have the runtime environment like Java or Python. Next, the dependencies of the application. And finally, at the top, the application code itself. By structuring images in this layered manner, Docker optimizes storage and speeds up image creation and distribution. Each instruction in a Dockerfile creates a new layer in the Docker image. Here is an example Dockerfile. It starts from Ubuntu version 20.04 as the base image. Then we update the package list. After that, we install Python 3. Then we copy the application code to a directory inside the container. And finally, it executes the application. So this Dockerfile will create 5 individual layers. One for the base image and one for each instruction. Layer caching provides several benefits. First, faster builds. Docker reuses unchanged layers, significantly speeding up the build process. Second, reduced storage space. Layers are shared between images, minimizing disk usage. Docker's smart caching system identifies unchanged layers and reuses them from previous builds. This saves time and resources. Docker checks each layer's checksum against cached layers. If a layer's checksum matches a cached layer, it's a cache hit, and Docker reuses the existing layer. If the checksum doesn't match, it's a cache miss, and Docker builds a new layer. This mechanism ensures that only the layers that have changed are rebuilt, optimizing the build process. To optimize Docker image builds, place frequently changing files at the end of your Dockerfile. This maximizes the chances of caching the earlier layers. Also, combine multiple run commands into a single one using shell scripting. This reduces the number of layers and improves efficiency. In this example, instead of having multiple copy commands, you can have one. Here are the key takeaways from this lesson. Docker images are built in layers for efficiency and reusability. Layer caching speeds up builds and saves storage space. Master Docker layers for faster, more efficient containerization. Thanks for watching. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.